Hello, everyone. Welcome back. Due to some crazy world circumstances, here we are doing our learning online. So I'm happy you made it here. Let's dive right in. The goal here is to start reviewing before we dive into some new stuff. So let's dive right into the warm-up. So as we go to the warm-up here, go ahead and pause this and try doing this video right now on your own. I'll give you a second to do that. Pause it now. Okay, now let's talk about how to do this. If this felt easy for you, fantastic. If not, tune in, let's go over it. I'm hoping you guys can see the document camera we have going over here. All right, so 1a here, we have the integral of 2x plus 5, this whole thing cubed. Just briefly, this is my first lesson like this for you all, so please forgive the inevitable mistakes that are going to come up. I'll try and minimize those as best I can. Okay, so we're going to integrate these things. Here we're kind of unchain ruling. For the unchained, the inside is going to stay the same. So I'm going to say this equals 2x plus 5. The inside stays the same. My exponent now goes to 4. I have to undo this exponent with a 1/4 out front. And then also as part of the unchaining, we have to undo the reciprocal of the derivative of the inside. And so I'm going to put a 1/2 out there. Again, the reciprocal of the derivative of the inside. And then we have a plus c. And for your final step, just go ahead and combine 1/4 and 1/2, and you get your end answer of 1/8 2x plus 5 to the 4th plus c box that. Well, all right, let's do 1b. 1b, the integral of 3 sine 2x minus e to the negative x dx. All right, let's dive in. So remember, constants being multiplied, they basically just stay there. You can bring it out for a moment and then put it back in. That's okay. So start off with, I know I'm going to have a 3 there. Now the integral of sine is negative cosine, so I'm going to put negative cosine. Now remember, this is kind of chain rule, and the inside stays the same, 2x. But then again, we have to undo what happens in chain rule, which means multiplying by the reciprocal of the derivative of this inside here. So I have a 1/2 that pops out there. So that's this part taken care of. Now let me worry about over here. So now I'm going to have a minus e to the negative x. But now I think through, if I were to take the derivative of this, e to the u times u prime, negative x would pop out. And so this this is really minus a negative, or I can just leave it as plus. And finally, because they're not bounds, we do need a plus c. And surely for your final step, if this were a test or anything, we'll have -3. We're combining the -3 and the 1/2. So -3/2 cos 2x plus e to the negative x plus c. All right, there's that one. Let's move on to part 2 now. All right, part 2. So here we have the area enclosed first. State the area enclosed by the two functions. Just as a brief sketch of what these two functions look like, let me sketch this for us. 2x is going to look something like so. 1/2 x squared, maybe something like that. Eventually up here they will intersect. My picture is not very good. But actually, I don't really like that picture. Maybe I'm just going to draw it like that a little bit better, just so we can kind of really see we're going to have these two intersection points here. First, of course, we need to figure out what those bounds are so you know where to integrate between. So I'm going to set 2x equal to 1/2 x squared. Let's solve for this. I'm going to multiply both sides by 2. So we get 4x equals x squared. Let's take the square root. Actually, sorry, let's just divide everything by x. You get 4 equals x. And there's one other solution that happens here. X can also equal 0 here. So I'm going to say can also equal 0. Both of those are valid solutions for that. Okay, so now for the area enclosed, we're going to integrate between 0 and 4 of the top function minus the bottom function. Remember, that's what we're doing here, top minus bottom. Here, the top function is 2x, so 2x minus the bottom, 1/2 x squared dx. All right, now to finish up this integration here, let's integrate each of these part by part. The antiderivative of 2x is just x squared. The antiderivative of this part, remember the 1/2 stays there, x. Now this goes up to the third power. But now remember we have to undo when this comes down. So just to show it, there's also times 1/3 here at the end between 0 and 4. And if you combine those right off the bat, that's fine. I just wanted to show what's going on with that. Oh, lost focus here. Sorry about that, guys. Okay, looks like we're all set now. Moving on. So now we just plug this in. So we have 4 squared minus 1/2, well, actually 1/6. Let me write this 1/6. 4 cubed, all minus. When you plug in 0, it's nice that all goes to 0. So 0. So we have 16 minus 64 divided by 6. 10 and 2/3. And so we should end up getting, what is that? 5 and 1/3 units squared. All right, there's 2a. Let's do 2b. So now state the volume of the solid created by revolving these functions about the x-axis. All right, so now for revolving, remember the big function that we're using, the volume equation, is pi multiplied by the integral of our function squared in between whatever our bounds are. Now, for one like this that has an upper bound and a lower bound, it's actually a slightly different equation, but it's similar. So I'm going to say this one is actually going to be the volume is pi times integral between whatever our bounds are, which I'll go in right in a second. Whatever the top function is, I'm going to say top squared minus bottom squared. We have to square those first before we integrate. That's really, really crucial. And you can't just square the whole thing. You have to square them individually. Remember, in short, what we're doing is we're taking the big revolution that would just happen if you just revolved. Let me just draw this in. If you just revolved 2y equals 2x, if you just revolve this piece, and then we're going to subtract out, what would happen? We're going to subtract out kind of this inner part there, the 1/2 x squared. So really we're doing this in two separate things. If this format is confusing to you, truly we're doing this as two individual ones. So it's pi a to b of the top thing squared dx minus pi between a and b of the bottom squared dx. It's just slightly shorter to write it here, but that's the same idea. Okay, so now let's actually do that over here. So pi volume equals pi. Here we already figured out our bounds are 0 and 4, 0 and 4. Our top function we said is 2x squared minus our bottom function, which is 1/2 x squared. And now we're going to square that whole thing again. Be careful with this. I'm going to go and deal with these squares before I deal with any integration. I should have the dx in there also. Now let's combine anything that can be combined. Now here I almost made a mistake. This square needs to be on the entire thing. If I just have it on the x, that's not right. It's squaring the entire function. So let me simplify this before I go about integrating it. So we're going to pi integrating between 0 and 4 of 4x squared minus 1/4 x to the 4th dx. Be careful with that one. I can definitely see some people getting tripped up there. Okay, onward. So now we can actually go about integrating. Let's integrate this thing. This is going to turn into x cubed, and then we'll have a 4/3 out front minus x to the 5th, 1. It's 1/4 times 1/5, or 1/20th. And we're integrating between 0 and 4, and we still have the pi out front that we multiply in at the very end. And we should have a v equals. All right, volume equals. Let's deal with this stuff. Oh gosh, fractions. Okay, so 4/3 if we plug in 4, that's 64 times 64 minus 1/20th, 4 to the 5th. We're just going to write it as 4 to the 5th now. I'll use a calculator in a second. And then minus 0, and we still have this pi out front. At this point, let's throw this into the calculator and see what we have. So 4/3 times 64. And now we're going to minus 1/20th times 4 to the 5th. And I get 34.13 pi units cubed. That's what our volume equals. All right. I hope you all got the same thing. If you have questions on any of that, we can definitely chat some more. Let's go on with what we were supposed to be doing here. I know that's kind of a long warm-up. We do these to review. It's really important to keep these skills going. I know my work was a little sloppy over there, so I also included similar work here. It's just there. Okay. Let's keep going. So next, if we were together, after the break, I was going to have us do a 4-minute challenge. Just keep these in our brain. The more you do it, the better it stays in your head. If this is something easy for you, great. If it's not something that's easy for you yet, keep practicing, guys. Okay, tangent values. Don't forget the tangent values. Remember, tangent is just y over x. Okay, unit circle. Internal assessment. Hopefully you have had a chance to turn that in. Guys, remember, I need to grade those. Each take about an hour to grade. There's 36 of you, so I need a lot of time to grade those. Okay, just briefly, the goal for what we're doing now for the rest of the time is reviewing some of the stats type stuff. Let me go right into here. So here in about a week, we're going to start some lessons on distributions. And before we start those, because they build on these earlier units, we're just taking a moment to review some statistics. So to do that, here's what I think is a good use of your time. There in our book, which is still posted everywhere, let's give these questions a shot. As far as the practice exam, I wanted to give that to you. I have not had a chance to give it to you, so I'm going to find a way to get those to you electronically. That's the plan for now. Give these a try. Remember, with this format now, you're going to take a picture and then upload those to your personal presentation, and it's just going to be an ongoing document with all of your work on there. Thank you for tuning in. Again, first video, a little bit rough. We'll keep getting better. Let me know if you guys have questions. Thanks.